Hello everyone, I'm Alfian and today we are going to solve the LeetCode challenge or the challenge number 69 called the square root of x. And for this particular challenge we are using the TypeScript as our language. If you want to use something else other than TypeScript, then go ahead. I encourage you to do so. And for this particular challenge, given a non-negative integer x, return the square root of x rounded down to the nearest integer. The return integer should be non-negative as well. You must not use any built-in exponent function or operator. For example, do not use power method with the text a parameter of x and then using the 0.5 in C++ or x exponent operator with the double asterisk with the 0.5 in Python to find the square root of the x as the answer. And we can use the math.square that takes the x as the parameter, and that way we return the answer. But then we should not use this one in our language, even though the JavaScript or TypeScript provides it. And so we need to opt to use the traditional method and traditional approach, and I will introduce you to the one method that is always showing up for this particular challenge. Let's say it's about using a formula that is always finding the exact answer every time by approximating the true answer of the square root. Okay, so for the example number 1 right here, we have the input x equals to 4 and the output is 2. For the explanation, the square root of 4 is 2, so we return true 2 as the answer. And for the example 2, we have the input x equals to 8 and the output is 2. Why it should be 2 is because the square root of 8 is 2.8 to something something, and since we round it down to the nearest integer, like it says from the one above, rounded down to the nearest integer, so hence the answer is 2. Okay, so for the constraints, we have inclusive number of the x, which always 0, range from 0 inclusive to the 2 with the exponent of 31 or the power of 31 and subtracted by 1. That is the possible value of x. And we have the function of called the square root that takes only one parameter called the x in the form of integer, and also the expected output is also in the form of integer. And for the hint right here, try exploring all integers. And for the hint number 2, use the sort the property of integer to reduce the search page, but I still don't understand what it means by the hints. Okay, so let's solve this out by declaring an edge case to check if the x is already 0. Using the string equals to 0, then we return 0 because we already know that square root of the 0 is always returning 0. Okay, so for the next one, we need to declare a method called the Newton formula, called the Newton's formula, mathematical formula. And for this formula, we need to find the approximate by declaring the x divided by 2, and that way we got the first guess. And for the second guess, we need to declare using the first guess added by the x and then divided by the first guess and then divided by the 2, but then it should be wrapped in a parenthesis, and then we got the second guess or the next guess. In short, it is about taking a guess, which is the first guess right here, but for the Newton formula, it is using the x divided by 2. Let's say we have the value of 8, x is equals to 8, and since it is divided by 2, and then the first guess will be 4, and the first guess is returning 4. And for the next guess, we take the guess as the first guess, and then we divide the guess by the value of the square root, and then added by that guess, and we need to divide the total with 2 divided by 2, and that way we got the second guess or the next guess, and we iterate over that each time to find if the first guess and the next guess, both of them has the difference below 1 using the tolerance of 1. We can use more precise tolerance by declaring other than 1. We can declare with 0.1 or 0.01 or 0.01 to be more precise, and that way we can get the exact value of the square root without depending on the square root formula or using the power of the 0.5. Okay, so let's implement this by creating the first guess using the let guess that takes the x itself divided by 2, and then the next guess as the empty variable. Okay, so for the next one we need to do at least one iteration, and then we can use the while loop afterwards. For this special while loop called the do, we need to do at least one calculation with the guess and the next guess, and we use the while true. After the do while loop true, we can return 0 if we don't find anything, or you can use the return next as the answer. But for this challenge, I'm using the return 0 instead to catch the function if the do while loop is not returning anything. So for the next variable, we need to declare the next equals to the, like I said, using this formula, this Newton's formula called the guess, and then added by the x divided by the guess, and then divided by 2. And don't forget to wrap this, because we are following the PEMDAS rule from this Newton's formula. PEMDAS rule, what it means, like we need to solve the equation from the p, which is the parenthesis, that is the abbreviation PEMDAS, and then the e, which is the exponents, using the power right here, or the power operator, exponents like 2 times 2 exponent 2 and then equals 4, or 3 exponent 2 is equals to 9, because 3 times 3 is equals to 9. And for the next one, after the e, which is the m, or the multiplication, and then m, or the multiplication, takes precedence over the division. And for the next one, which is the division, so that is why I am using this guess plus the x divided by guess. But as we know that the JavaScript or TypeScript will calculate the parenthesis first and then the division first, and division takes the precedence over the addition. And then the D stands for the division. For the next one, which is the A, stands for the addition. And for the x divided by the guess, and we got the answer. After that, we add the guess with the calculation from the x divided by the guess, and after that we divide this by 2 since the parenthesis takes first. Okay, so that is the short explanation of the PEMDAS rule. And since we already got the next value from the next variable, we need to compare if the next using the Math.absolute to check if the difference between the guess with the next is lower than 1 using the tolerance of 1. Let me declare the let tolerance equals to 1, and then we can use the tolerance as the statement right here. If it is, then we return the answer as the rounded down answer. I'm declaring the Math.floor first, Math.floor with the rounded down of the next value. And if it is not, then we need to simply assign the guess with the next. How does this work? Let's say we have the value of 8, the x equals to 8, and then we need to guess the 8 using the guess equals to 4. So that is the value of the guess from the x equals to 8. And for the next one, we have the next value of the guess from the guess plus the 8 divided by the guess and then divided by 2. But then since the parenthesis takes first, it's supposed to be 8 divided by 2 is equals to 2, added by 4 equals to 6, and then divided by 2 equals to 3. And we got the next guess as 3. And we need to compare the 4 with the 3 to check if it is lower than 1, not equals to 1 but lower than 1. Since 4 and 3 is equals to 1, then of course it is still equals to 1, and that way the if check will not triggers, and we assign the guess with the next variable, and that way we are assigning 3 as the guess. And for the next variable, we are calculating the 3 plus the 8 divided by 3 and divided by 2, and we got the answer of 2.83. And we take a if check if the is in the math absolute to check if the 2.83 or the 3, because guess takes first, 3 subtracted by 2.83 is lower than 1. If it is, we are returning the next as the answer, but then we should floor this, and then we use the 2.83 and we use the floor and we return through 2 as the answer, because 3 subtracted by 2.83 is equals to around 0.17, I believe. And since 0.17 is below than 1, then the if check will triggers and we return the floored value of the 2.83 of the next variable. And what about other example? Let's say we have the x value of 100. As we know that 100 square root of 100 is equals to 10, but what if we don't know the square root of 100 at all? We can use the guess equals to 50, because 100 divided by 2 equals to 50, and then for the next equals to, let's say we have the next of the 50 adds the x, which is 100 divided by the 50, and we got 52, and divided by 2 and we got 26, and we got 26 as the next answer. But then since 50 and 26 is far apart from the 1, the difference is not below 1, then we need to declare another do while loop using the guess of the new guess of the 26 and the next variable or the next value of around 14,92. Since 26 is still far away, 26 with the 14,92 is still far away from tolerance, which is 1, then we need to do while loop again, guess, the next one will be guess 14.92, and the next value is supposed to be around 10.81. And since 14 is still has the difference around 3, then the if check will not triggers, and we need to use the do while loop again, and with the assigning 10.81, the next property should be around 10.03. And this fourth iteration, we have the difference of below 1 because of the 0.81 and 0.03 is around 70-ish, 0.70-ish, and then it is still below the tolerance. Then we return the Math.floor of the next value that it is about 10.03, and we return 10 as our answer. So that is the answer of the 100 square root without using any method at all. So let's run this. That is the magic of using the Newton's formula. You might want to check it out on Wikipedia or Geeks for Geeks or anything else as you want. Okay, so let's run this out to see if it works. Okay, so as we know that the magic formula, which is the guess, that guess takes the parameter divided by 2, and we add the number itself divided by the guess itself, and we add the guess and we divided this by 2 in order to find the nearest value of the square root. So that's about it. I hope you understand my explanation. If you still don't understand, you can ask me in the comment section, or if you have any better solutions regarding challenge, tell us what you think in the comment section. Thank you for watching the video. I hope you have a great day, and I will see you in the next video. Goodbye.